Okay, in this video I'm going to talk about electrical loads in series and parallel. So remember, just a brief starting point here. The word load means a device that's using electrical power. So we might have something like a light bulb here. And our general symbol for an electrical load is the resistor symbol, although we can use things like light bulbs and other symbols like that to represent the different types of devices that are using the electrical power. Okay, so series and parallel. First of all, what does it mean to be in series, or what does it mean to be in parallel? Series means in a line. So two resistors that are in series looks like this in a circuit. It's one path, and all of the current goes through that one path. In parallel, that means beside each other, or that means multiple paths. So here, where we have one track for the electrons to move around, here we have different paths, multiple ways where the different electrons could go. So what will happen? Well, here, these two resistors will get together and make a big resistance. This means if these were something like light bulbs or something like that, they would get less power. Now this can be a good thing or a bad thing. If you're operating, for example, on a battery, then using less power means that you're going to have a longer battery life. Alternatively, if you're dealing with something like your light bulbs, it might mean that your light bulbs are dimmer or not as bright as you expected them to be. Here, because we have multiple pathways, just like multiple highways to get around on the road, we're going to have a lower resistance. Here, each one of these resistors is being powered separately, so we end up using more power. And so this means brighter, but say shorter battery life. And this one says dim, but longer battery life. So you can see how those two things can play in as either an advantage or a disadvantage to those types of circuits. The other advantage, disadvantage, and this is the most, maybe the most critical one, is with a parallel or with a series circuit. If you put a switch in, that switch will control both loads at the same time. They're either both on or both off. Alternatively, with a parallel circuit, if you put your switch in at different locations, you have the ability to control each light bulb separately. This switch would control this light bulb. This switch would control this light bulb. So the loads are controlled separately, which means you can have one on at a time. This is obviously a really big advantage. If you imagine, for example, the lights in your house or something like that, it would be silly to have to turn every light in your house on at the same time with the flip of one switch, it makes much more sense to control the individual electrical devices separately so that you can use power in the ones that you want and not use power in the ones that you don't want. So here, this power situation is an advantage and a disadvantage depending on what it is that you're trying to accomplish. But this switch situation where you can control things separately is clearly an advantage for parallel circuits. So that's not all the considerations with electrical loads in series and parallel, but there's a couple. That's what it means to be in series or in a line, just one path, or in parallel beside each other. And there are some of the basic advantages and disadvantages of each situation.